we're 3 minutes past the starting hour. Welcome everyone. We are very happy to host you for yet another edition of our distinguished lecture series. Today we have a very special guest who is going to be sharing with us experiences around hold on one second, let me okay, for whatever reason there we go. We'll be sharing with us a very interesting talk around ethics and computational systems in general. And I think Lorena takes a pretty unique view as to the approaches to assessing kind of ethical issues and you know, the fact that they often get projected down to purely kind of mathematical and algorithmic issues. But it is my pleasure to welcome Lorena to another edition of the Institute for Experiential AI Distinguished Lecture Series, where we feature external speakers and who talk about their significant work to our community interested in AI and experiential AI. Lorena is a consultant and scientist, and she really works between kind of the digital technology and ethics worlds. She works for the European Parliament and the European Commission. And of course, she hails from Spain. Her own government asked her to be on the National Council on Artificial Intelligence. She founded a nonprofit organization, the Ethical Tech Society, where they look at questions in ethics and legal philosophy and how that works in this new world with lots of digital transformations. She's also a co-founder of the AlgorithmWatch initiative. And we look forward to kind of hearing her thoughts on, you know, what are these ethical issues we need to think about, and in particular, how do they map to algorithms and technology practice in general. So with that, thank you for joining us, Lorena, and welcome. And I'll turn it over to you for the presentation. I'll remind everyone, please post your questions into the chat or the Q&A, and I think Ricardo will administer the Q&A session. So we'll collect your questions, no interruptions during the talk, and then we will address them towards the end of the time slot. Thank you. Lorena, over to you.
Thank you very much, Osama, for the kind invitation and introduction. It's a pleasure to be with all of you. Let me start by sharing. I brought with me a presentation, of course. Yes, it's working. So as Osama said, I want to talk about ethics and computational systems in general. And I want to address how we've been dealing in the past years with ethical issues and why those approaches within computational systems are bringing quite a narrow perspective on how to deal with disparate impact, discrimination issues, and other harms that might happen as a form of involuntary damage when we use those systems in the real world and apply them for things that have a societal impact or a high stake impact, let's say social services systems or credit scoring, or in the health sector. There's many of those issues that of those systems that are becoming more and more part of our daily lives and our daily architectures, and more and more we've started to realize that there is a societal and social and ethical dimension in all those systems, that technology is not neutral. Now, Are we really starting to realize now that these technologies that are part of the orchestration of and the administration of our lives have a societal dimension? Actually, no. But what is clear is that if we look back at how we started making science, what strikes the most is what you're seeing on the left is the tree of science painted by Ramon Llull, who was a humanist, who was one of the pre-humanists. He was a philosopher and a monk living in the Middle Ages, in the late Middle Ages, and he was one of the pre-thinkers within the world of the humanism and the thinking of the humanist thinking. And what we see from the very beginning is that science started to specialize more and more, and that the more knowledge that was produced, the more it was separated in disciplines and in language that would become the technique part of the instrumentarium and part of the technicalities of a very specific approach to the scientific approach to the world. So what you see in this tree is something that has by now multiplied and growth exponentially. We have so many disciplines and sub-disciplines, and scientific output is growing exponentially every year. So what we see in that, from that perspective, is that really getting a sense of how our discipline is connected to other disciplines has become slightly difficult because of that massive amount of output produced in science on the one side, but also because of the ramification of every discipline in so many other disciplines that already we see in the own sector. We might find so many disciplines that it's almost very difficult to really to look across many other sectors that are contiguous to the way how we do science, but are far away. Let's put an example with social sciences and humanities and its intersection with specific scientific approaches. So what we're seeing now, it's actually not new. And the social dimension of engineering, the social dimension of technology is also not a new thing. If we look at the beginnings of the century, if we look at the beginnings, of the 20th century, the idea of the future became closely related to technology, and engineers and statisticians became part of the academic elite that was meant to shape societies. And there were an international elite of working engineering communities that understood that what they are doing is creating and shaping societies through the creation of infrastructures. In those days, of course, they were thinking about material infrastructures such as cables or the routes for highways or streets and mobility connections. But in the very end, led by mathematical thinking and by statistical thinking and by an approach to the architecture of society that, as they thought, would lead to what sociologists call Mannheim called the end of unplanned things. It was about, based on understanding and mathematizing the world, creating a planification for the future. And with that, overcoming subjectivity in politics. So in conferences of engineers, the tone was very much about how engineers would create the new politics of the city and of the states by creating infrastructure that is led by mathematical thinking, and with that would overcome the so-called subjectivity of politics. Now, that is part of the story that we forget in our discussions when we talk about the social dimension of computational infrastructures, because it seems so far away from our discipline, but it's very close connected to the thinking, to the technical thinking behind both computational infrastructures or engineering thinking. And another reason why it's so difficult to talk between disciplines that are so far away from each other, specifically the ones that really cross fundamental borders regarding approaches and methodologies, is also related to what Timnit Gebru in her talk in this distinguished speaker series at CDAC categorized as the hierarchy of knowledge. And what we see, and she was addressing also together in a conversation with Ruha Benjamin and Meredith Whittaker, is the fact that we see a prioritization of natural and mathematical sciences as the neutral, so-called rational sciences, and the social sciences as being more softer and more prone to subjectivity. And for that reason, of course, trying to bridge all those differences, both methodologically and also in the language, becomes one of the main challenges that we have nowadays. And they come not from something that is happening now, but it's a historical development that we've been having for the past 400 years. Even though the initial thinking that led us to things like artificial intelligence as an idea and so on was social thinking. Humanism as a philosophical movement is very much actually the father and the mother of many of the scientific approach that use mathematics and statistics to systematize the world. And with that, it is the father and the mother of artificial intelligence as a form of systematizing and automatizing processes. Now, for that reason, because of all the things that I was mentioning before, we need to keep talking and remembering and redoing and rethinking again and again things that have been said already in the past. So many of the issues that I'm addressing here and that are hot topics in our actual conversation at the intersection of ethics and technology are not new. Already Donna Haraway in the 1970s was talking about how human engineering was a form of changing the way how we organize societies, and she was really addressing technology as a form of control and as a form of creating impact at a whole new level. Also, Richard Levantine, at the very end of the 80s, beginning of the 90s, was writing biology as ideology and also addressing some epistemological concerns in the way how we try to do natural sciences. And it was not only addressing problems within the idea of biology, but addressing general problems that we see in the concept of natural sciences and the ideas behind the concept of rationality and neutrality. Also, people like Helen Nissenbaum and Deborah Johnson in the 90s were already addressing the impact of computers and the need for ethics in this field, long forgotten and not anymore part of this conversation with whole new protagonists nowadays. And even more far away from the conversations that we have now, but are the basis of many of the conversations that we should be having, is the work of people like Chela Sandoval, who is a professor for Chicano studies that has been influenced very much by the work of Donna Haraway and was already in the 90s addressing how technology has a societal impact that might affect especially marginalized communities. And even though those works are there and there is a rich and vast material in the scientific sectors addressing all these issues, we are reviving all these issues without looking back at history and trying to grab all the findings and all the and all the positions that we have been developed for the last 60 years. And when it comes about computational systems, one of the things that I think it's important to remember were already described by Norbert Wiener in The Human Use of Human Beings already in the 1950s, where he was trying to make the point that the way that communication and the way how we are using technologies is about precisely establish a certain level of control. So this systematization of the world through technology and the systematization of the world through mathematization of the world was not about simply organizing the world, but was in the very end a form of control. And the question here, of course, when we talk about control is control towards what and against what. And he was quite clear in pointing out that this is control against nature and nature's tendency to entropy. So the point that Norbert Wiener was trying to do is a point that nowadays is being raised more and more by ethicists and sociologists, that when we create the structures are more than individual services that have a direct impact on individuals and might harm their individual rights, but go beyond that, because those computational systems are actually infrastructures, and as that, they are shaping the societies we lived in, and as such, they have a scalability that lead to a different type of impact in the societies that we have than simple individual harm. Those are computational structures of controlling and shaping groups in society and shaping how they interact, how they communicate, and to a certain level to contest the nature that Wiener was talking about. Control and optimize nature. So what we see and that technology is about through the lens of humanistic thinking, which is very much the inspiration behind those ideas of optimization of nature, being the human nature as we see with its exoskeleton, or of nature overall. That type of control that becomes optimization and is very much marked by our occidentalized humanistic thinking, has a lot of additional purposes that I think are important to bear in mind when we are talking about the systems that we're using and to what extent they are fit for the society that we want to shape with those systems. And in this sense, when we talk about optimization and control of nature, we talk of that optimization in a form of efficiency as a form of optimal adaptation to the existing environment. That's the understanding. So it's really very much about trying to make the future based on the past, and less on trying to create a future that has nothing to do with what the past has done. And in that sense, what we see in the field, and I want to bring a few concrete examples of how our discussions around algorithmic fairness or algorithmic justice and ethics in this field look like. When we talk about these conversations, we see that there was a crucial point happening in the 2016, 2017, where Jo Wallenbini would present one of her project for her dissertation for her PhD at the MIT, called Coded Gates, where she would demonstrate how computer vision was biased and was racially but also gender-wise biased towards white men, and in detriment of women and people of and non-white people, so people of color. And from that moment on, we saw a huge amount of different measures to address those problems. That those measures would go over the creation of the conference called Fairness, Accountability and Transparency, now called ACM FACT, and it went over ideas of creating algorithmic systems that are just by design, or would go over measures to create techniques of explanation of what the algorithmic systems are doing and make them less of a black box, or would go into suggestions of so to say data parity, or that, which is a different thing than data equity, the fact that we have more varied data, or more heterogeneous data of diverse forms and groups of people, does not necessarily imply that they are being treated in a fair way. So parity and equity are not the same thing. And what we saw around those conversations were the focus on, among other, Compass, which was one of the most spoken or most talked about systems, and because of the algorithm of the algorithmic report of ProPublica with Julia Angwing, showing with a specific methodology that it had an impact on Black and racialized communities, that that was detrimental for them. And around those conversations, many other risk recidivism systems were analyzed. For instance, this one in Spain. We have also risk recidivism programs. And the basically idea of the whole conversation was trying to see how we can create those systems more fair and avoid discrimination by just using either more categories, more specific attributes, or bettering the data, which has led to people like Latanya Sweeney to talk about problems that may arise with this idea of making data more inclusive, which she calls predatory inclusion, because in the end, it is not about making the context of usage more fair, but the systems more fair, which is a slightly different thing. And what we also saw, for instance, in our conversations, were the case of the For You page algorithm. TikTok has this For You page algorithm where people and accounts are being suggested to you, and it was found out last year that it is racially biased, and there's a specific realm where content creators can offer and commercialize what they offer, and they were complaining about TikTok filtering them out. And the suggestions that TikTok came out with to avoid or to circumvent this alleged filtering was creating diversity boards where creators would make sure through different techniques that this and through different initiatives that the algorithm has more varied data and is able to circumvent this effect. Also, oops, I forgot. Also, what we also find is in the concept of or in the whole discussion around Facebook and many other social media, and this is a slightly mistake that you see in my presentation. I'm sorry. It was meant to appear. It has two levels. So what you see behind this Network Enforcement Act was meant to be a screenshot of how Facebook was addressing how they do their content moderation, which is basically based on three pillars. One is detecting specific wording, the other is prioritizing that wording, and the other is deprioritizing specific forms of content. And this was the result, among others, of regulation, like the German Network Enforcement Act, which was in the very end making the argument that even though content moderation has its flaw, it's more, it's rather and better able to deal with those huge amounts of contents that should be, according to the law, filtered than human work. And this Network Enforcement Act has seen a lot of revisions. It's now the third one, trying to cope with the fact that content moderation is always biased, specifically in languages that we have not enough data of, and where engineers lack the cultural insights of the context where this is being applied. And another approach that is also within these discussions that we have around the impact of technology and how technology on the one side conflates and amplifies already existing discrimination. There's also the other side of the argumentations portraying technology as a neutral, rational, objective technology that might help us to debias human and unconscious biases. So around all these discussions, the focus is the technology that we have and the systems that we have and how they are implemented and how they are computing the specific process in a way that is fair, be it either by design or be either with good data set, good well-structured data set, and how it can be optimized from the data science perspective. Or it also focuses on what type of metrics can we use to translate fairness and justice and ethical principles into mathematical context. Now, what the conversation until now has not been doing is to ask about and get more knowledge about the usage of those systems. Initially, Angel Christine, which is a professor in Stanford University, started asking during the whole discussion about Compass how the uptake of Compass as a tool looked like, how many judges were really following the recommendations. But it was not until a few weeks ago, a bit more than a month ago, that Ben Grimm brought this study where he systematically gathered data about how judges were acting and reacting towards these technologies. And the results are pretty pretty interesting. And they're interesting because what he's showing is that even though the algorithmic systems might be more or less fair, humans interpreting the results were not that much led by what the results they are saying, but also by their own prejudices. Meaning with that when they were evaluating black defendants, they would rather decrease their estimate of risk suggested by the risk assessment when it was white defendants, and they would increase their estimate of risk according to the algorithm. So they would just go in either a more positive view for white defendants and even decrease their estimate, or in a more negative march and even increase the risk assessment performed by the system. So the second part of the study became then also part of a very important point in all these conversations that we have when we talk about ethics in the context of algorithmic systems. Since most regulation right now are demanding a human in the loop to avoid automatization. And what Ben Grimm came out with in his study is that people were really not able to evaluate the quality of the systems that they were using. So the system was neither helping them to overcome their bias and was not, so to say, clear or transparent enough and understandable enough, legible enough for the judges to really understand how good the quality of the system was. And more of it, what the system was doing is putting and formalizing a lot of criteria that need some revisioning here. Because if the system was not improving the accuracy of human predictions, and that is the first question, what is a human prediction in this context, and what is a human mistake in this context? If a judge thinks that someone asking for parole might be low risk and grants that parole, and that person afterwards commits a new crime, is that a human mistake? Just simply because the person committed a new crime? What are the elements that we need to analyze to think about it as a mistake? Because that was part of what was seen, identified as part of the criterion to make the system more accurate. But the fact that a judge grants parole has many, many different factors that need to be considered when deciding whether to grant parole or not. And that might be the law, specific law regulations that even though the risk might be high because of the way how the parole was asked, because of specific parts of the process, might lead to the judge to have no other option than to grant parole. So it might be perfectly fine, and it might not be a mistake that a judge grants parole, and yet the person commits another crime, because in this context, risk is one of the many other factors that need to be weighed in a specific situation as this one. And with the introduction of these systems, what we're doing is formalizing and documenting the idea of risk and centering it into the middle of the considerations of a judge, while all other factors that need to be considered are remaining not documented or even unformalized. So when it comes to the usage of these technologies, I think that there is also an additional aspect that we need to consider here, and it's outside of the system itself, the algorithmic or the computational system itself. And it starts with the idea of ethics and the idea of justice. In our thinking, the idea of ethics and justice has, specifically the idea of justice, has or is based in the notion of social stability, of equal dignity, and of human relationality. So it's not about the truth. It's not about giving to each other what belongs to each other or to someone. It is about render to each his due, as Platon said. And what this means is that justice is a very specific form of operationalizing fairness and operationalizing and enshrining into law a specific idea of what we consider to be a good order, an ethical order. And the ironic part of that is that in the moment where we enshrine in law what we consider that is a fair process, what we consider that is a just value, justice becomes external to the legal system and remains outside that system as a form of comparison. So not everything that that we do in law is necessarily ethical, and not everything that we do in law is necessarily fair. And the point of fairness and justice as fairness within this conversation is that it is about trying to overlook from a fluid, conversational, societal perspective to as a point of comparison to see whether the way how we organize our society normatively, so with laws, is in the very end, as a result, fair. So there comes the idea from justice as fairness and as a structure from Rawls, when he talks about justice and as fairness, and meaning with that justice is a structural thing, and it's about a basic structure in society that understands that relationality between human beings. And when we go back to all the systems and look at the principles that we were talking before, using these technologies to optimize, specifically, let's use the idea of optimizing granting parole in the justice systems. It has a lot of presuppositions. When we decide that we want to optimize through automation, what we are saying is that the past is so good and so unbiased that it can be used as the proxy and as the norm to be applied for the future. And because it's so good, we can obscure the language used by mathematizing and making categories that are stable and that will not be under constant review, so that we can keep on using them. But the funny thing of fairness is a different one, and I will go into that in a second. What it also presupposes is that the application, the application is stable. So what it presumes is that we want the future to be as the past. And what it also implies is that the datafied part of the process is prioritized over all other aspects that remain either not documented or not included in the system. So when it comes to justice, this is slightly difficult. Because the nature of the systems that we are talking about is a stable nature. It's a nature that tries to understand the similarities and the behavioral patterns when it comes to human beings and extract the individualities to make general assumptions about human beings and about the similarities between human beings and the differences between human beings. Whereas ethics and justice is about contextualization. And yes, there is a systematization part of it, which is the legal part, where we try to structure the processes and the way how we give each its due or his due. But that systematization, it's not about the profiles of the people, but about the specific facts in a specific case, and trying to contextualize throughout all the different systematizations of law and understand whether the case that we have in front of us does apply to the general rules or it's an exception to the rule. And of course, the relational aspect in the justice context, in the fairness context, is not about trying to extricate the particularities of individuals to understand what similarities they have to other people, and based on that, make a decision about that person. And the relational part is about what we owe to each other, what society owes to an individual to make sure that we have social stability. It is not to make a judgment based on what similar profiles have done in the past of a specific individual. It is not about trying to put that individual in a specific drawer and say, just because someone with his similar characteristics did in the past something, had this profile, you are probably going to be behaving in a similar way. No, it's not about that. It's precisely quite the contrary. It's about really pointing out at the possibility, at the contextualization of the person in his environment and what makes him and his particularities a person where change or might be plausible. It's also about not the person itself, but it's also about the specific facts. So to sum up, if a process is algorithmically fair, it is probably socially unfair because it lacks the capacity of contextualizing, which is one of the main points of fairness. And if we try to use these systems in a different way, which we can, because this is not about, or what I'm trying to put here is not to say that because the essence and the meaning of justice and the meaning of fairness, it's something different from what the nature of computational structures can do. And because of that, because those two natures are different, and because justice is about understanding individual and contextualizing individual particularities in a specific case, whereas computational systems are more about understanding in the way how we use them right now, about understanding particularities. I'm not saying that we should not use them in the justice system or that we should not use them in other systems, but what I'm trying to put on the table is that the context of usage doesn't make sense. If we want to understand specific patterns of behavior from the past in specific contexts, like the justice sector or the hiring sector or the health sector, those type of infrastructures might be helpful to understand specific patterns of behavior or specific commonalities. And for that purpose, it might be very useful. But those are not the approaches that we're using in the occidentalized culture of machine learning and more complex technologies that are being used in our everyday lives. They are being used for a purpose of optimizing and personalizing services, which means that we are evaluating and judging individuals based on profiles that have nothing to do with their particularities, but with our idea of what profile they belong to. And for that, they are useless. So making assumptions about or understanding more about our society from a perspective that is more focused on the relationships instead of the nodes and the dynamics instead of the nodes might be very useful. We see a few examples that that go away from these approaches, rather Occidental and European approaches in the very end of technology usage, and try to create a more relational perspective. And those are things like self-organization principles that are being encoded. This is a paper of Gustavo Carreón and Carlos Gerhensson, and they were creating models that were more focused on understanding how self-organization processes happen and less interested in optimizing how drivers drive or how we can optimize transport. And in the very end, it became even more a successful model than other models. And this is another example that has been that happened last year. The Australian wildfires, we'll remember that, were a problem, a big problem. And in a combination of indigenous knowledge and modern techniques, different entities computed and their rituals into calendars to understand when they could intervene when there were fires. So they were not understanding fire as something that they need to, where they need to optimize how firefighters enter that situation, but they were rather more focused on understanding fire as a process, and they turned out to be very successful. So looking perhaps at how nature works, which has been there longer than we human beings, looking at the woods, it's perhaps also a different approach that has been more and more part of new thinking in indigenous communities and other communities that have a more relational focus approach to that technology, that in the very end is a technology that understands the woods and understands less individuals. Thank you very much.
Thank you, Lorena. A lot of things to think about. Let me see that I have my question myself, and I have some pre-recorded questions, but let me, Joe, do you want to ask your question yourself, or I do it for you?
Hey, thanks, Ricardo. Can you hear me?
Yes, go ahead, please.
Okay, thanks a lot, and thank you so much, Lorena. I'm blown away. I'll try to keep it short. Do you believe from your experience and exposure that it's reasonable to ask or expect a team of technicians, scientists at a company like Facebook, for example, to learn the history and appreciate the global phenomena of colorism, racism, misogyny, heteronormativity, etc., or is that a pipe dream? Is it good enough to simply deconstruct the illusion of overcoming what you call the subjectivity of governance? Thanks.
That's a fantastic question. Thank you very much. And it's so important. I think that is part of the conversations that we all need to have right now. Because our future is entangled in the past, and there is no such thing as objectivity. What we have is what we consider to be objective, all things considered under specific circumstances, and that objectivity is always connected and correlated to the culture and the position of the speaker and the person observing and creating. So yes, I think it's possible. I think it's becoming sort of a momentum, but those momentums come and go. But what we see is that more and more communities connecting those dots between older colonialist thinking, racist thinking, and trying to connect the dots with how we systematize through mathematics and the implications behind many of the assumptions that we have. On the other side, what worries me is the Cold War rhetorics that we have right now, both in the US and the European Union, where there is this race for machine learning and race for quantum computing, and where no one wants to lag behind, because it, on the other side, negates the fact that we are all connected to each other and that we are all dependent from each other, because the whole life cycle of technology is already a international affair, right? It starts with mineral resources that are outside Europe and to a certain extent also outside the US. And in continents that are less, so to say, are less involved or are less on the receiving end of computational structures and services, like Africa and Asia, that are not really receiving any benefit of the computational of the technologies that we develop, but are donating or are being extracted. And it also negates the whole life cycle. I mean, many of the waste that is produced by technologies land somewhere else in the world, but not in Europe and not in the US, or only some parts of the US it still does, and some parts of Europe still does too as well. But mainly it's somewhere in Mongolia, mainly it's somewhere in Africa, and we trade that off. So negating that reality is also an impediment to realize that we cannot talk anymore about American or European technology, but that this is really a technology that is showing how we interrelated we are. So I think it has to be bottom-up movement. So I think it's also you all, people working in this field, that it's also on you to reflect on this. It's also on you to demand for change, and it's also on you to and on us, civil society and people from different disciplines, to really demand better, starting by recognizing, which is also something that we need to do not only in Facebook, but also NGOs and politicians and civil society, both in Europe and the US, need to recognize that they are wrong in many things, that they need to listen to other communities that they have been silencing, because they were more interested in saving them from barbarism, from a settler colonialism defined idea of barbarism, than in really understanding what are their needs and how they look at the world. So it's not only the task of those big tech and big data firms.
Yeah, so we have several questions, so let's try to answer fast a couple of them. There are many more, but I think Victor Maojo has a question that is interesting, and then also Sama has a question. So Victor, do you want to do the question yourself?
Yes, yes. I have one small problem because I cannot see it now, not well, but I can say it in different words. Yes, you were talking about a theorem, which is if a process is algorithmically fair, it probably is socially unfair. I wonder if this theorem is also biased. It could be biased, but based on the experience that could be also biased, no? Because, well, many people are talking that all data are biased, but this is not always true, no? And, well, what do you think about that? Do you think that also this is something like politically, socially, well, to say that now, but I don't know why this theorem is not also biased.
Thank you so much. And well, the theorem was a fun way of formulating the fact that fairness is not, it's ironically something that you cannot systematize. And in the moment where you're systematizing, you're killing it. So that's the reason why injustice we say that a judge does not impart justice, it imparts and it applies the law. And we say that because the judge knows that some laws might be fair, but some other laws might not be fair. And we know that some judgments of the judge that simply really are strictly using the legal instruments that he or she has to apply are not shrined in stone, are not set in stone, but need some sort of a societal review, because otherwise law would not evolve. And it evolves because society evolves, because societal expectations evolve, and because what we considered 100 years ago as to be fair is not considered fair anymore. And because of that, fairness escapes every type of categorization, be it mathematical or legal, but it's a form of shadow that it's sort of looking there, and it's sort of indefinable. And we all have our own idea of fairness, and it's part of our societal conversation, and it's part of what conforms the public opinion that is always creating societal expectations. And this is what, for instance, there's an element in justice that judges apply in criminal law, and that is even when they apply all the law that they had to, and they come to a specific decision, they can try to prove whether in the societal world of lay people that that decision would be considered as fair. And that is a sort of proxy to really understand, are we going legally and in the realm, in the right direction, or are there things that we need to rethink both as judges and from the legal perspective? So that's why I was saying that.
So,
okay, thank you.
we have many questions. I think we don't have enough time, so I don't know if you can stay longer for a small
Yeah, I can
group.
do.
But Osama wants to have questions to finish the proper time, and then we can continue discussing, because there are very interesting questions going on. So, Osama, do you want to make your question?
In the last few seconds, I guess I would ask, I mean, you did a great job of outlining the issues and how thorny they are, and in fact, you know, sometimes they lead to impasses. But one of our philosophies in the Institute for Experiential AI is we recognize there are all these issues and problems, yet we have to live with them. So maybe in 10 seconds, I know that's a challenge. Can you summarize, like, what would be a takeaway on what do we do here, you know, to kind of take a better approach? Like the short answer, we know that it's thorny and all of that, but what would be like your very short advice to everyone?
In Spain, we have a saying that says something like, you cannot demand pears from an oak. You can only demand pears from a pear tree. So I think that the way how we're using computational infrastructures, ironically, is a child of our thinking, but it doesn't fit the expectations that we have on it. It can do other things than the ones that we are doing with it. So I think that we need first to realize what is it fit for before keep on trying to make from an oak a pear tree.
Well, thank you, Lorena. Let's finish the recording here. A great presentation, and I would like to remind all people that in 2 more weeks we have Jennifer D talking about AI applied to Heuss. So thank you, Lorena, and we will stay, everyone that wants to stay, to keep talking with her, because we have so many questions pending.
Thank you very much.